Now we are going to learn how we can apply vectors to do some uniform velocity question. Okay, so let's talk about kinematics first. Okay, so when you are presenting displacement, okay, when you are presenting displacement, you must remember, okay, displacement can be given as a function of time. Okay, it can be any function like t squared plus 2t plus 1. Okay, so this decides at a specific point of time. Okay, if t is equals to 0, at time is equals to 0, the displacement of the object will be equals to 1. Okay, so normally it is given in seconds and it is given in meters. The unit is meters. And when time is equals to 1 second, okay, the displacement is equals to s of 1 is equals to 4 meters. Okay, similarly, it goes on. Okay, so when time is equals to t naught, we can say the displacement of the object or the particle is s of t naught, and that will be equals to t naught squared plus 2 t naught plus 1. Okay, so this is what you did when you were working with kinematics, and you differentiated the function s of t to come up with the velocity of the object. This is the normal things that you have already studied. But now we are going to represent the position of a particle. Okay, the position of a particle by using the equation for a line. Okay, the vector equation for a line. We know the vector equation for a line. Okay, so for a line is given as r equals to a plus lambda t, lambda b. Okay, so it is given as r is equals to a plus lambda b. There a is a point on the line and b is the direction of the line. So we normally call it the direction vector, or this one is the position vector, and r represents the motion or the point on a line. It can be used to find the this equation can be used to find the position of a line. So a position of a point. So when you consider a particle, okay, when you consider a particle, let's say a particle is A. Okay, let's say a particle A is there. Okay, particle A must have a position, right? In the vector space, we can actually provide a point, a position vector. Okay, so if I consider, okay, if I consider this as the space, and we can name I, K, and J, all are perpendicular to each other. This is the origin. Okay, if I consider this the origin, A has a specific position vector, and that can be represented as OA. Okay, that can be represented as OA. And the fun part about this is, if the particle A travels in a straight line, okay, if it is traveling in a straight line motion, I can use the vector equation. Okay, I can use the vector equation for a line to track its motion. All I need is the direction vector or the velocity in which it's moving, and then a point where A could move. Okay, and what is lambda? What will lambda do here? The lambda will be the time. Okay, so I can use this for the for tracking the motion of the particle A in a straight line. Okay, so it can be used for a straight line motion. Okay, so let's write them down. Okay, so A is the point on motion path, or the path, point on path of A, point on path of A, path of A, and lambda here will represent the time, and b will be the direction vector or the velocity of particle A, velocity of particle A. Okay, so what will r represent? R will represent the position vector, okay, the position vector of A at a specific time, position vector of A at a specific time. Okay, so this is what we have to know to apply vectors in the straight line motion. Okay, so position vector of A at a specific time. Okay, how can we do this? Well, let's start with a simple example. Let's start with a simple example. All right. So let's say the motion of a particle A is given by R is equal to A plus TB. Okay, I'm using T. Why? That will be easy to understand as time. Instead of lambda, T is a little bit easier for us to understand. Okay, so let's say A is equals to 1, 2, 3, and B is equal to 4, 5, 6. Okay, so if I draw, if I draw the motion of the line, let's say the motion of the line is going to look like this because it's the equation for a straight line. Okay, so when t is equal to 0, when t is equal to 0, a is going to be at 1, 2, 3. This point, let's say this is point p0. P0 will be, P0 will be 1, 2, 3. When time is equals to 1 second, when time is equals to 1 second, let's say this is P1. P1 will be, can be given as 5, 7, 9. 5, 7, 9. And when time is equals to 2 seconds, let's say that is point 2. Point 2 can be given as 1 plus 8, 9, 2 plus 10, 12, and 3 plus 12, 15. So this is what's going to happen. This is what's going to happen. And I can actually track infinite number of points. Why? When I substitute the value for t, I can actually derive and come with different position vector of different points on the straight line. Simple as that. Okay, simple as that. But there is also another important thing. What? Well, magnitude of b. Yeah, magnitude of b. Magnitude of b will give us the speed of the particle. The speed of the particle. Okay, why is that possible? Well, velocity function of a particle can be given as a function of t, and that is given as v of t. Okay, if you find the modulus of the function, you will find the speed in kinematics. Illaya? Similarly, here also, if you find the magnitude of speed, magnitude of velocity, I don't know, I can't speak English. So magnitude of v will give us the speed of the particle. Okay, so let's practice this with a question. Okay, let's practice this with a question. Okay, so let's keep it simple. Let's say the motion of a particle. Okay, the motion of a particle in a straight line can be given as, what is the displacement of the particle? What will be the displacement of the particle after 10 seconds? Well, if I draw a straight line, okay, let's say this is a straight line. And when time is equal to 0, t is equal to 0, the particle will be at, let's say, A. Okay, let's say it is at A. So A can be given as 9, 8, 9. Okay. And when time is equal to 50 seconds, time is equal to 50 seconds, I can say, let's say that is particle B. Well, then I have to find the particle B. So I will just find the position vector of OB. So OB is equal to 9, 8, 9 plus 50 into 2, 3, 2. Well, that will give me 109, 150, 158, 109. Okay, that's great. That's great. Okay, so this is the point B. B can be given as 109, 158, and 109. So if I have to find the displacement of the particle in t is equals to 50 seconds, I can just find the length of AB. Okay, I can just find the length of AB and come up with the answer. Okay, so length of AB is equals to, it's in the space. Okay, it's in the space. So I can apply the equation for a straight line. Okay, a straight line segment. So that will be equals to square root of, square root of 109 minus 9 whole thing square plus 158 minus 8 whole thing square plus 109 minus 9 whole thing square. Okay, so that will be equals to 100 squared plus 150 squared plus 100 squared. Okay, 100 squared can be written as, 100 squared can be written as 50 squared into 2 squared. Okay, similarly 150 squared can be written as 50 squared into 3 squared. So that will give me, if I take 50 squared as a whole, as a common factor, that will give me 2 squared plus 3 squared plus 2 squared. Okay, and the final answer will be equals to, that will be equals to 50 square root of 4 plus 9, 13, 13 plus 4, 50. Okay, I can say meters. Why? It's normally given in standard units. But if they change the unit, they will let you know in the question. Okay, it can be kilometers per hour, then you will give it in kilometers. But normally it's in meters and seconds because they are the standard units. Okay, so here I want you to look at something. So since the particle is moving in a straight line, okay, since the particle is moving in a straight line motion, it's following a straight line motion and it's moving in a straight path. We know the distance is equal to this distance. Okay, if a particle is moving in a straight line without changing its direction, distance will be equal to displacement. Okay, distance is equal to displacement. So in this question, you can do it in another way. Okay, you can do it in another way. So first of all, you can find the speed of the particle. Okay, speed of the particle. So yeah, I'll write it here. I think I have space. Speed of the particle will be equals to modulus of 2, 3, 2. Okay, what have I written here? Will you can give the vector in this form also if you want to save space inside angular brackets. Okay, so that will be equals to square root of 2 squared plus 3 squared plus 2 squared. So that is equals to square root of 17 ms minus 1. So that will be the speed. So they're asking what's the displacement in 50 seconds. So distance is equals to displacement. So you know speed is equals to distance over time. So distance is equals to speed into time. So distance is equals to speed into time. Okay. So in this case, speed is equal to root 17 and time is equal to 50 seconds. So the final output will be 50 into root 17 meters. Okay. This is only applicable if the particle is not changing the direction. If the particle is not changing the direction. So yeah, this is useful. If you found this useful, apply it. But or else you can apply this way and find the answer. However, okay, fine. Now let's do another question. Okay, now let's introduce two particles. Okay, let's say a particle A is starting at origin 0, 0, and the velocity vector is given as the velocity vector or the direction vector is given as, let's say that is VA. Okay, VA is given as 3I plus 4J. Okay, at the same moment of time, B is starting at I don't know 20, 15. Yeah, it doesn't matter. I'm just using two specific vectors here because that will be easy for us to understand and visualize. So VA and the velocity vector is given as, let's say it is 2I minus 5J. Yeah, 2I minus 5J. Okay. Now they are asking what will be the distance between A and B, particles A and B, in, let's say, 20 seconds. Yeah, T is equals to 20 seconds. Yeah. So when you face a question like this, first of all, you have to draw. Okay, first of all, you have to draw, or else you will definitely make mistakes. Okay. So I mean, not definitely, but you know, it's easier when you draw things. Yeah. So let's do that. Okay, you may think why I am acting weird because I am high on caffeine now. So yeah, it happens. So I hope you understand. Okay, so A is starting at here. Okay, A is here, and B is at 2015. So it is 20 and 50. Say here, blah 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 blah. So this is when A and B are there when time is equal to 0. Okay, I'll use a different color to show when what's in what direction they are going to move. Okay, they're saying A is moving 3I plus 4J. Okay, so 3I, 3 in this direction and 4 in this direction. So it is moving in this direction. So the straight line will look something like this. The straight line will look something like this. This is the motion of particle A. And what about particle B? Well, that is 2I minus 5J. Okay, that is 2I minus 5J. So 2 in this direction minus 5 in this direction. So the particle is moving in this direction. So the straight line path of B will look like this. Okay, so they are getting away. They are getting away. Obviously, that's what they are telling. And they are asking us to find the separation between these two particles at time is equals to 20. So let's say this is time is equals to 20. When time is equals to 20, particle A is here. And let's say particle B is here. I don't know exactly. This is not up to scale. This is not up to scale. So if the particle B is here, we have to find the length between these 2 points. Okay. So we can apply the equation there to find the values. But first of all, we have to find the points. We have to find the points. So first of all, we will write the particle A's movement in the direction of, according to the vector equation. Okay, so for A, the vector equation must look like R is equals to 0, 0 plus time into 3, 4. And for B, it should look like, okay, for B, the equation must look like 2015 plus t into 2 minus 5. Okay, so when time is equals to 20, the position vector of A will be, let's say, OA. Okay, so this is A0, this is B0, and this is A, and this is B. Okay, perfect. OA will be equals to 0, 0 plus 20 into 3, 4, which is equals to 60, 80. 60, 80. Perfect. 60, 80. And similarly, I can find for OB will be 2015 plus 20 into 2 minus 5. And that will be equals to 60 and minus 100, so minus 85. Okay, so now we know the position vectors of A and B at t is equal to 20. So the point will be 60, 80, and point B will be 60 minus 85. So to find the length AB, okay, this guy, AB, we have to find that guy. So AB is equal to square root of, okay, square root of, who is in upper hand? Obviously, is in upper hand. So, well, 60 minus 60. They're in both same. That's a nice coincidence. Yeah, that's the same I point. So I coordinate. So that's good. And 80 minus minus 85. Okay, 80 minus 85 whole thing square. So that is equal to 60 minus 60 is 0 plus 80 plus 85 is equal to 165. 165 whole thing square. 165 square. So that is equal to 165 meters. Since the time is given in seconds and the movement of particle is given in meters. Okay, the displacement of the particle is given in meters, so it should be how it is done. Okay, so I hope you understand. I'm gonna do different types of questions in application of vectors, only based on the velocity, and then wait for the next video where we will be discussing about some more questions. Thanks for watching the 18th video in our vector series. If you found this explanation of applications of vectors in kinematics helpful, don't forget to like, share, and subscribe for more tutorials. Hit the bell icon to stay updated with our latest videos, check out the full playlist to master vectors, and follow us on Instagram. I'll see you in the next video. Until then, keep learning and stay curious. Bye-bye.